Okay, so here are the notes for solving quadratics by factoring when a is equal to 1. So important information here. Factoring is the process of breaking large expressions into smaller parts. It's the inverse of distributing, so it's technically division because distributing is multiplication. It's possible to factor quadratic equations to linear factors. So linear just means they have regular x's, not x squareds anymore. If you graphed a linear factor, it would graph a line, so linear. You have all the terms on one side of the equation. Usually we do this so the x squared term is positive just because it makes the math easier in the end, but if you want to leave things where x squared is negative, it is doable. So you're going to find two numbers, x1 and x2, that multiply to the value of c and add to the value of b. The factor expression is written like this, so x plus x1, x plus x2. So the x's, regular x's will stay x's, x1 and x2 will be numbers. If x1 or x2 is negative, there will be subtraction signs here instead of addition signs. So sometimes they might not all be positive, so we have to have rules for determining which factor is positive, which one is negative. So if we say that x2 is always the larger of the two factors, x2 is more than x1, you can use the table down here to figure out which one has which sign depending on the values of b and of c. So if c is greater than 0, so positive, less than 0 would be negative, over here, positive and negative. So if both c and b are positive, both factors are positive. If c is negative but b is positive, the smaller factor is negative, the larger factor is positive. And then so on and so forth, you can use these rules. So I'll be referring back to this table as we work through the problems. So once you have it factored, we take each factor separately and set it equal to 0. This is what's referred to as the zero product property. If you multiply two things together and your answer is 0, it means one of them has to be 0. Because the only way to multiply two values and get 0 is if 0 times something, or something times 0. So let's look at the examples. So example 1. So first step, move everything to the left. So we got to move the 3 across. So we would actually have x squared plus 4x minus 45 equals 0. So what I need to do is I need to find the factor pairs for 45. Now, you should always approach this in the same way every time. I always put the smaller factor on the left, the larger factor on the right, and I always go in an increasing order. So 1 and 45, 2 does not go into 45, so we skip over it. 3 does, 3 and 15. 4 does not go into 45. 5 does, 5 and 9. 6 doesn't, 7 doesn't, 8 doesn't, and then we're back to 9, which we already have. So these are the 3 factor pairs that make up 45. Now, my c value is negative and my b value is positive. So if c is negative and b is positive, we're in this box down here. x1 is negative, x2 is positive. x1 is always the smaller, the one on the left. x2 is always the larger, which means in these factor pairs, they have to be like that. The smaller factor is negative, the larger factor is positive. And then I need the pair that adds up to positive 4. Well, that pair adds up to 44. Can't be that. That pair adds up to 12. Can't be that. That pair adds up to 4. So when I factor, it's x minus 5 and x plus 9. So then to solve each factor separately equal to 0. So add the 5 across, positive 5, and negative 9. Okay. So for number 2, we need to bring the 2x and the 2 across. So I'm not going to show my work there. So if I add the 2 across, I get negative 13x. If I add the 2 across, I get positive 30. So I'm looking for the factor pairs that make up 30. So 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6, and that's it. So there's 4 factor pairs. Now, last number is positive. Middle number is negative, so the rule on the previous sheet, c is negative, or c is positive and b is negative. So c is positive, b is negative. Everybody's negative. Both x1 and x2 are negative values. So negative 1, negative 30, negative 2, negative 15. So remember, this left-hand column is always x1. This right-hand column is always x2, the smaller of the pair. So that's why you should be consistent in your ordering. So I need to add up to negative 13. Well, that's negative 31. That's negative 17. There's negative 13. So x minus 3 and x minus 10. So x minus 3 is equal to 0. X minus 10 is equal to 0. So x is 3 and x is 10. what I'm about to do there is that once you know the factors, if the a value is 1, the solutions are just the opposites of the factors. So since the factor is x minus 3 and x minus 10, the opposite of negative 3 is positive 3. The opposite of negative 10 is positive 10. Okay, so for 3, we got to move the 10x and the 4 across. So if we subtract the 10x, it's just going to become negative 10x. If we subtract the 4 across, we get positive 21. Gives us this. So I need the factor pairs that make up 21. So smaller and larger. So 1 and 21 works. 2 does not work. 3 and 7 make 21. 4 does not. 5 does not. 6 does not. The next one is 7. So since that's positive and that's negative, it's the same rules up here. Both factors have to be negative, and that's the pair that adds up to negative 10. So x minus 3, x minus 7. So the solutions will be positive 3 and positive 7. Okay, so for 4, subtract the 3x and the 3 across, so x squared minus 3x minus 4 equals 0. So I need the factor pairs for 4. Note that when you're doing your factor pairs, you're not worried about this sign. This sign doesn't come into play until we need to choose whether our factors are positive or negative. So 4 is 1 and 4, and 2 and 2. Last c is negative and b is negative. So if c is negative and b is negative, or in this box down here, so the smaller factor is positive, the larger factor is negative. So the 1 and the 2 are positive, the 4 and the 2 over here are negative. Now for the 2's, it's a bit tricky because they're the same size, so just 1 is positive and 1 is negative. We have to add up to negative 3, which has to be that pair. So x plus 1 and x minus 4. So x plus 1 could be 0, or x minus 4 is 0. So x could be negative 1, or x could be positive 4. Okay, got 3 more here. All right, so for 5, everybody to the left, so x squared plus 12x, when I subtract the 6x across, plus 35 equals 0. So the factor pairs for 35, 1 and 35, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 and 7, and that's it. Since c is positive and b is positive from the previous sheet, everybody's positive, adds up to 12 is 5 and 7. So x plus 5, x plus 7. So set the factors separately equal to 0. So there's your 2 solutions. Let's see, so this one we'd have to subtract the 7x across, which gives me negative 11x, add the 28 across, gives me this. So the factor pairs for 28. 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, 5 doesn't work, 6 doesn't work, and then I'm back to 7, so these are my pairs. So since this one is positive and that one's negative, from the rules on the first page of the notes, if c is positive and b is negative, everybody is negative. x1 and x2 are both negative. And there's the pair that adds to negative 11. So x minus 4 and x minus 7. So x minus 4 could be 0, or x minus 7 could be 0. So positive 4, positive 7. All right, last one. So if I add the 5x across, I get 1x. Then that's going to be negative 20. So the factor pairs for 20, 1 and a 20, 2 and 10, 3 doesn't work, 4 and 5, and that's it, because the next one would be 5, which I already have. Since c is negative and b is positive, the rule is going to be that x1 is negative and x2 is positive. Set that adds to positive 1. It's the last pair. So the factors are x minus 4 and x plus 5. Set them separately equal to 0 and solve. So for negative 5. That brings us to the end of the section.